Good morning, good afternoon, good evening, depending on the time that you are listening or watching this video. My name's Akanyanta Victor. I'm the lecturer at ZAPTAC. I take DA2, DA3, and DA5 for Zika. I also do FMA and F1 for ACCA. Today, I want to talk to you about investment appraisal techniques. Here we are going to consider how major investments are assessed, or how to assess the viability or profitability of investments or projects. Before we begin to go into the details, I want you to get ready with a piece of paper or a book, a pen, and a calculator, because I want you to participate as well. I want you to be following through as I'll begin to calculate. There are a number of different methods which can be employed to assess the value of an investment or project. These methods include the payback period method, the net present value method, and the internal rate of return method. And I intend to cover these three methods in this particular session. But before I start looking at the details here, I want to give you a brief understanding of what each of these methods imply. So method number one, or technique number one, payback period. What's the payback period? The payback period is the length of time the investment takes to pay itself back, or it's the time taken for the initial investment to be recovered in the cash inflows from the project. Usually this method is relevant if there are liquidity problems, and the project that has got a shorter payback period will be considered the best project. Technique number two, the net present value method. Under the net present value method, we take into account what is called the time value of money. What is the time value of money? The time value of money is the fact that the money you have now is worth more than the same amount of money received in the future. Why is that the case? It's because of the following factors. Number one, it's because of inflation. Prices of goods and services increases with time. So what you can get from the same amount of money now will be much more than what you can get from the same amount of money given to you in the future. The second factor is the opportunity cost. The money you have now can be invested for you to earn a return over a period of time. So the money you have now is much better because it can earn a return over a period of time than the same amount of money you expect to receive in the future. So those are some of the reasons why we must consider the time value of money as we assess the viability of projects. That's what net present value is all about. So under the net present value, we take all the estimated future cash flows, discount them to the present values, and then compare them with the cost of an investment. If our NPV is a positive value, then we say the investment is viable and should be taken. If the NPV is a negative value, then we say the investment is not viable. If you have got different mutual projects that you want to take and you need to choose one of them, then you go for the project with the highest net present value, because that will be considered to be the most profitable investment. The third technique is called the internal rate of return. Now, this technique uses trial and error to discover the discounting rate, which produces the net PV equals to zero, and that will be considered more like a break-even rate. So all the projects, for the project to be acceptable as viable projects, they must bring in a return that is higher than the internal rate of return. All right, so before we begin to look at these three techniques that I've mentioned, I want to remind you of some of the things you already know. things like the calculation of interests, how interests are calculated. Now I'm going to run through this part as quickly as I can because we need to get back to the calculation of those techniques, investment appraisal techniques. So simple interest is one of the methods that can be used to calculate interest. The other method is called compounding, or calculation of compound interest. So the simple interest, under the simple interest, the interest does not earn interest. The interest earned on an investment does not earn an interest on it. And the formula for calculating the future value or the future amount that one will have in an investment under simple interest is given as follows. So future amount equals to the present amount, or the principal invested now, multiplied by 1 plus Rn. In this formula, FV stands for the total amount of money at the end of the period. This will be the total sum that will be in an investment at the end of a period. The PV stands for the amount invested. You can also call it the principal amount. R stands for the rate of interest, and N in the formula stands for the number of periods. So let's consider our example number 1, or exercise number 1. How do we calculate simple interest? So we are told that $1,000 is invested at the start of year 1, and the simple interest is added each year at 10% per annum. How much income will be in the investment, or how much income will the investment generate by the end of 2 years? So the first thing you need to do in a question like this is to identify the variables that are given. Identify the variables that are given. So let's look at the variables that we are given. Firstly, according to the formula, we are given the PV, the amount of investment, the PV. So our PV is $1,000. $1,000. The next thing that we are given in the question is the rate, R. The rate is 10%, so R equals 10%. R is 10%. That 10% as a ratio, it will be 0.1. What else are we given? We are given the size of N. We are given the size of N. What is N? Is the number of periods. So in this case, the number of periods N is 2 years. Okay, so 2 years. So how do we calculate the total sum? You go back to the formula, just check the formula again. The formula is future value, the total sum, equals to the present value multiplied by 1 plus Rn. So let's get this formula and substitute the variables that we are given. So this is going to be equals to, what is the PV? 1,000 multiplied by, what is our R? So multiplied by 1 plus R is 0.1. Just check, that's 10%, multiplied by, let me use the other multiplication, multiplied by the size of N. We are told that N is 2 years. So when you tap that into your calculator, you have 1,000 multiplied by 0.1 multiplied by 2, that is going to be 0.2 plus 1, that will be 1.2. So tap that into the calculator, you have 1,200. 1,200. So $1,200, $1,200, that will be the future value or the total amount of money in an investment after 2 years under simple interest. Here, interest is not earning interest. So you calculate interest on the straight line basis. So that's how we calculate simple interest. So if you have not understood, pause the video and go back a little bit and just go through what I've done again. That's simple interest. The second thing I want to remind you of, I know you already know this, is the calculation of compound interest. Now, under compound interest, the interest is added to the principal before the next interest is calculated. In other words, the interest also earns interest. That's how we calculate interest under compounding method. So the formula is the future value, the total sum you expect in the future, equals to the amount of investment now, or the principal amount, multiplied by 1 plus r to the power n. This part, 1 plus r to the power n, is what is called the compounding factor. So in other words, the future value equals to the present value multiplied by the compounding factor. Let's look at our example number 2, or exercise number 2. 1,000 is invested at the start of the year 1, and compound interest is added each year at 10% per annum. Calculate the value of the investment at the end of 3 years. Again, this question is similar to the first one we have dealt with, except that now we are dealing with compound interest, not simple interest. So again, you do the same things that we did with the first question. Number 1, identify the variables that are given in the formula. So what we have is the PV in the formula is given. If you want, you can just copy that formula down there so you can make proper references to it. Okay, so 1,000 is invested. That's our PV. So PV equals 1,000. I want you to be doing the same things I'm doing on your piece of paper or a book, that you may have a feel of what is going on here. So PV is 1,000. It's invested at the start of year 1, and compound interest is added each year at 10%. So that's our rate. Rate is given. The rate is 10%. And that as a ratio is 0.1. Per annum, calculate the value of an investment at the end of year 3. So we are given the period. So that's our N. N is the number of periods. Now let me talk about N. N is the number of periods. So this can be annual periods, or sometimes it can be periods less than a year. For example, it can be a monthly, daily, or quarterly, or semi-annually. So you just need to calculate the number of periods you have. So for example, in this case, if interest was calculated quarterly, and we are looking at the period of 3 years, the question you need to ask is, how many quarters are in 3 years? We have 4 quarters in each year, so times 3 years will end up with 12 quarters. So your N is going to be 12. And if you do that, also R must be adjusted in that case. So if it's interest calculated every quarter, R, which is 0.1, will be divided by 4 to bring it down to the period quarter. I hope in one of the sessions, or when we come to the revision, we'll deal with more questions that involve compounding in periods less than a year. But let's continue with this one. So we are looking for the total sum. N is 3 years. That's what we are told, 3 years. So what's the total sum that will be in this account or investment at the end of 3 years? So you say sum, that's the future value, FV, will be equals to, what's the present value? The principal amount invested now, that's 1,000, multiplied by 1 plus the rate of interest 0.1 close brackets to the power n. That n is 3. Now to the power n to the power 3. Let me just write the power 3 properly. All right, so that makes a lot of sense. Now tap that in your calculator. You have 1.1 to the power 3 multiplied by 1,000. 1.1 to the power 3 multiplied by 1,000. You should get 1,301. So the total sum of money in this investment will be $1,331. $1,331. You can pause the video and try to work this one out on your own and see whether you can manage to do that. All right, so we've looked at how interest can be calculated using simple interest method or using compound interest method. Now let's look at discounting. What is discounting? Discounting can be explained as reverse compounding. Here we are taking the future value, estimated future amount, and discount it or bring it down to what that amount could be in the present terms. So we are reversing the compounding. So if you look at the formula for calculating present values, it's just the opposite of calculating future values under compounding. So we say present value is equals to the estimated future amount multiplied by 1 plus r to the power negative n. 1 plus r to the power negative n is what is called the discounting factor. The discounting factor. This is the factor you multiply by any future amount in order to bring it down to the present value. Now, discounting is a method that looks at the time value of money. The time value of money. I've told you the reasons why the amount of money you have now is more variable than the same amount of money received later in the future. It's because of inflation. I've talked about inflation, which is the loss of purchasing power of money, or because prices of goods and services are increasing, you can only manage to buy less from the amount of money you have if you are to buy these things later in the future. There is also uncertainty issue there, and also the opportunities of investment or the opportunities to invest. It's a lost opportunity. So if that money is not given to you now, you have to wait for it, say in 2 years' time. What you are losing out now is an opportunity to invest that amount of money and gain a return on it. So that's what discounting is all about. Now let's look at the exercise number 3. Exercise number 3, it involves calculating the present value. So it says calculate the present value of 80,000 at the end of year 5 if the interest rate is 10% per annum. So what is happening here is that we are given the future value and we are told to calculate the present value. So how do we calculate the present value? Look at the formula. Present value equals that future value multiplied by 1 plus r to the power negative n. So let's see. Our PV, present value, equals to the future value. How much is the future value? We are told this is supposed to be $80,000 multiplied by 1 plus ARA. What is the size of ARA? Again, we are dealing with 10%. So as a ratio, that is going to be 0.1. Close brackets to the power negative n to the power negative n. Let me just write the power negative n property there. Okay, so we have it there. Power negative n. So this is going to be equals to, again, tap in your calculator. When you add what is in the brackets, that will result in 1.1 to the power negative n. What's the size of n? We are told n is 5. So this will be something like this: 80,000 multiplied by 1 plus 0.1, that is going to be 1.1. Then this you raise to the power minus 5 or negative 5. So again, this must be properly presented as the power negative 5. Right, so we have it there. So this is going to be equals to, now let's put everything in our calculator, follow bit mass. It's a 1.1 to the power negative 5. Then your answer multiplied by 80,000. If you do that properly, you should get 49,674, of course, rounding off, $49,674. That's the present value of the 80,000. So to be promised 80,000 in 5 years' time is equivalent to receiving 49,674 now. That's how much that 80,000 received in 5 years' time is worth now. Again, I should say you can pause the video briefly and try to assimilate everything that we have talked about so far. So far we've looked at how to calculate interest using simple interest method, how to calculate interest using compound method, and how to calculate the present values given the future amounts. So now let's begin to look at the details of the investment appraisal techniques, starting with the first technique called the payback period. First technique called the payback period. I just hope you are enjoying what's going on, and I hope this is helpful. Please, you need to give us feedback on how this program is going. All right, so payback period. We've said payback period is the length of time it takes for cash inflows from trading to pay back the initial investment. That's what is called payback period. So where you are given the initial investment and the annual cash flows, payback period can easily be calculated as the initial investment divided by the number of the annual cash inflows, the amounts of those annual cash inflows. For example, please do not worry about the numbering of examples. I think the numbers were jumbled. We are just from number 3 to number 10. Do not worry about that. But let's continue. We are told that a company invests in a project with an initial cash outflow of 100,000. Cash inflows resulting from the projects are 40,000 per annum. Calculate the payback period. This is simple. You are looking at how long it will take for you to recover the 100,000, which is the initial investment. So if the net cash flows are 40,000 per annum, how many years is it going to take for you to recover 100,000? So all you need to do is say payback period is going to be equals to, how much do we need to recover? It's 100,000. That divided by the amount of money we are receiving as cash inflows per annum. That is going to be 40,000. Okay, so tap that in your calculator. What is 100,000 divided by 40,000? You should get 2.5. Now I want you to understand something there. 2.5. 2.5. So what is this 2.5? This 2.5 is years. This 2.5 is years. But there is something to this. What does this imply? It implies that the project will take 2 years and 50% of the third year to pay back. 2 years and 50% of the third year to pay back. So how do you convert that into actual months? Because this is not going to go to 3 years. It will be beyond 2 years and 50% of the third year. So you have 2 years, of course, 2 years, after 2 years, plus what is 50% of the year? We know that there are 12 months in a year, so we get 50% of that. That is going to be 0.5, 50% multiplied by the 12 months of the year. 12 months, that makes 1 year. So 12 months there. And so at the end of the day, we are going to have 2 years and 6 months. 2 years and 6 months. So the payback period for this project will be 2 years and 6 months. The 6 months is the 50% of the third year. 50% of the third year. That's how you can calculate payback period, having been given the initial cash outflow and you are given the annual net cash flows. Now let's look at another example, a little bit comprehensive example of the payback period. This is exercise number 11. Of course, don't worry about the numbers. A company makes an investment with an initial cash outflow of $1 million. Cash inflows resulting from the project are as follows. So you are given the cash inflows for the next 5 years. The question is, calculate the payback period. So what we are saying here is, how long will it take? How long will it take for these cash flows to amount to a $1 million? A $1 million. So what you can do here is either you take 1 million and begin to subtract the cash flows from there until you reach 0, or you can cumulate the cash flows on a separate space, cumulate the cash flows until you reach the 1 million. So let's do this. I would prefer we use the accumulation method. So let's just let me insert a table there. We need how many columns? 1, 2, 3, 4, 5, 6, 7. We need about 7 columns, 7 rows, and about 3 columns. 7 rows and 3 columns. So let's do this one as fast as we can. Okay, so let's insert that table and try to work with it. In an exam, you really need to be fast about this. You need to be fast about this. So years, we have year 1, year 2, year 3, year 4, and year 5. Right? Then the cash inflows. So we can say the net cash flows. The net cash flows, we have 100,000. Then you have 250,000. The next one is 350,000. The next one is 360,000. and the last one is 500,000. So on this other part, the column there, you need to accumulate. So cumulative cash flows. Cumulative cash flows. So for year one, you have 100,000. For year one, you have 100,000. So if you had the cash flow for year two as well, what will be the cumulated figure? It is the 100,000 plus the 250,000 for year two, and this will amount to 350,000. You have 350,000. If you had the third year's cash flows, the cumulated figure will come to 700. So 350,000 plus 350,000, that will give you 700,000. Now, if you had the fourth year's cash flow, you will discover that you go beyond the 1 million required. We just want 1 million. So meaning that the project will pay back before year four finishes. So how can we convert that into actual years and months? So obviously we have established from the table that this project will go beyond 3 years. So we have 3 years, but how many months? So how do we calculate the months? Look at how much is remaining for you to reach the target of 1 million. You want to pay back 1 million. You are already at 700,000. So how much do you need on top to reach the 1 million? You just need a 300,000. 300,000. Now, this is going to be divided by the total cash inflow for year four, which is 360,000. Total cash inflows for year four, 360. So what ratio is this? So put the brackets there. The ratio you have here should be multiplied by the number of months in a year. So how many months do we have in a year? We have 12 months in a year. So this will result in the number of months that will take. Tap that into the calculator. You will have something like 9.9, which is rounded off to the nearest whole number. This is 10 months. 10 months. So what's the payback period? So finally we conclude. The payback period is going to be equals to 3 years, 3 years and 10 months. 3 years and 10 months. That's a payback period for this project. Remember I said how do you assess the viability of the projects? When you are using the payback period, it's the project that has a shorter payback period which is preferred. And the reason is the payback period method is relevant where there are liquidity problems, meaning that the company wants to get back its invested cash as soon as possible. Let's move on to the net present value method, which is the second investment appraisal technique method. Net present values. Now, net present value, consider the time value of money. I've already talked about this. So everything, this is very key, everything is compared in present terms, in PV terms, present value terms. So all the future estimated cash flows must be discounted into present values, then compare that with the investment cost or cash outflow. If your NPV is a positive value, you accept the project. If the NPV is a negative value, you reject the project. If you are picking between mutual projects that have got positive NPVs, then you have to go with a project that has got the highest NPV or positive NPV. So let's look at that example that we have here. I hope we'll work through the example as fast as we can. Okay, so in this example, a company is evaluating a project that has the following cash flows. It will purchase a machine on January 1, 2011 for $50,000 and will receive net cash each year from the trading activities as follows. So we have those cash inflows. The company can borrow money, that's the cost of capital, can borrow money at 10%. Is the project worthwhile? So let's see if the project is worthwhile. So what do you need to do? For simplicity's sake, you create a simple table that can help you work out the figures. So this table is going to have 4 columns, and counting the number of rows, that should be about 5 or 6 different rows. So let's just insert a table that can help us work out this. So 4 columns, 6 rows. Okay, so let's see how this is going to work out for us. So in the first column, you will put years. Second column, that is going to be your net cash flow. Net cash flow. Your third column will be the discounting factor, DF, discounting factor, DF. Now you remember the discounting factor in the formula. Let me just show you the formula I'm referring to, the discounting formula. This formula here. I said the discounting factor is 1 plus r to the power negative n. That's what you multiply by the future amount in order to get the present value. So guess what is happening in our table down here? These are future cash flows, estimated future cash flows, estimated future cash flows. The table is here. So estimated future cash flows are here. That's what we are calling the net cash flows. Discounting factor, that's the factor. However, you can get the discounting factor values from the discounting factor tables or the present value tables. Don't go to the cumulative one. We explain about cumulative discounting factor or cumulative present value tables when we talk about annuity. For now, you will just go to the present value tables and get these DFs. Okay, so when you multiply the discounting factor with the future value, that should give you the present value. Now the discounting factor is at 10%, at 10%. So if you go to the discounting, if you go to the present value table, you go to column 10%, and begin to pick the values. So let's see, year 0, we have year 1, year 2, year 3, and year 4. There are 4 years here. So what is year 0? You may be wondering, what does that mean? Year 0 means now. So what is happening now is that the company must spend $50,000 to acquire or purchase a machine. So the $50,000 is the cash outflow. So we put it in brackets like that, the cash outflow. Then in year 1, which is 2011, there will be a cash inflow of $20,000. In year 2, which is 2012, there will be a cash inflow of $10,000. In year 3, 2013, there will be a cash inflow of $20,000. In year 4, which is the 2014, there will be a 15,000 cash inflows. All right, where do I get these values? These are the cash flows that are given in the question. Then we come to the DF. The DF at 10%. In year 0, it's always going to be 1.00. But year 1, if you check the table, you must get 0.909. For year 2, from the table also, you get 0.826. Year 3, you will get 0.7, 0.51. Year 4, you'll get 0.683. All these figures, you just get them from the table. So how do we get the present values? When you multiply the cash flow by the discounting factor, you get the present value. So 50,000 paid out multiplied by 1, it's going to be 50,000. 20,000 multiplied by 0.909, you should get something like 18,180. 10,000 multiplied by that one is quite straightforward, 8260. 8,260. Come to your year 3, 20,000 by 0.751, you will get 15,020. 15,020. Year 4, you'll get 15,000 multiplied by 0.683, you should get 10,245. Please go through these figures and just verify the figures. So what we need down there now, we need to calculate our net PV. What is our NPV? What is our NPV? So net present value is just the net of all the present values that we have calculated. The net of all the present values that we have calculated. So adding the inflows and subtracting the outflow, you should get a positive 1,705. So where is the 1,705 coming from? 1,705 is a result of adding or summing up these cash inflows. When you get the total, then subtract the cash outflow, 50,000. You have a remainder of 1,705. This is the positive cash flow. So the conclusion is that the project is profitable. The project must be accepted. The company should go ahead and invest in that machine. So that's how we deal with the net present values. Let me deal with the last but not the least of the techniques. That's the internal rate of return. Now I said this technique uses trial and error to find a discounting rate that gives the NPV equals to 0. And that becomes more like a break-even rate. Any project that cannot yield a return up to that rate or more is going to be rejected. So only those projects that are going to give us a return that is higher than the internal rate of return are going to be accepted. So calculating the internal rate of return, you can either use the formula or use a graph. When you use a graph, you are plotting between the NPVs and the rates. So NPV will be the vertical line, the rate will be the horizontal line. Later I will be able to show you that. Once I get the graph, I can just paste it on this document. The formula, internal rate of return equals the A% plus, so that's A% plus. Let's just try to edit the formula here. It's A% plus, A% plus. The formula must look like that, A% plus. So what's A%? A% is the rate that gives us a positive NPV. So that positive NPV, we say, it's going to be called A. Let me just pause a bit. Wow, let's continue from where we had paused. Somebody walked in the room and to pause a bit to attend to them. But let's continue. So I was talking about the formula. So A is that rate that gives us a positive NPV. So that positive NPV is going to be capital letter A. B percent is the rate that gives us a negative NPV. So that negative NPV is going to be the B rate. So let's look at exercise number 6. Probably we'll end with that exercise. A project costing 1,000 will return a 1,108 pounds in the following year. What will be the net PV at a discount rate of 10% and 20%? Then using this information, calculate the internal rate of return. So we need to calculate the NPVs first. So what are NPVs? Present cash outflows minus the present value of cash inflows. Present value of cash outflows minus the present value of cash inflows. So let's work with the table as quickly as we can. So this is part of the solution. Okay, so since now we are just dealing with year 0 and year 1, we just need about 3 rows in the table. Let's insert the table. Insert table. 4 columns, of course. 3 rows will be sufficient. So what we have in column number 1, that's the year. Okay, so year. Then what else? Cash flow. Of course, this is going to be a net cash flow. Always remember, this is a net cash flow. Net cash flow is where you have subtracted the cash outflow from the cash inflow in each of those years. Then we have the DF, our popular DF discounting factor. You can get that from the table. So this one is going to be at 10% because we are given 2 rates there. So let's start with the 10%. Then we have the present value amount. So what we have, investment in year 0 and the cash inflow in year 1. What's the investment in year 0? We are told this is 1,000 pounds. And what's the cash inflow in year 1? That's 1,180 pounds. The DF at 10% for year 0, it's going to be 1.00, and at the DF at 10% for year 1 is going to be a 0.909. What are the PVs? So that is going to be 1,000, and this one is going to be 1,073. So tap that in the calculator. You should have 1,073. Then there we have 1,000. We have 1,000. So what's the net PV? What's the net PV? So NPV. What's the NPV? NPV will be a positive value of 73. Just look at the difference there. So the NPV is 73. Positive value 73. So that's at 10%. Now let's borrow this table and try to use it. Try to use it for the 20%. So at 20%, the DF will change, and so these values also should be deleted. So what will be the DF at 20%? Year 0 is always going to be 1.00, but year 1 at 20%, from the table you should get a 0.833. 33. So what will be the PV? That is going to be 1,000. That's going to be 1,000, and this is going to be 983. That's 1,180 multiplied by 0.833. So in this case, what will be the NPV? In this case, what will be the NPV? The net present value, how much would that be? So you aggregate between 1,000 and 1,080 and 983. Sorry, I forgot to put the brackets there. This is the negative, it's a cash outflow, so always remember to do that so that you are reminded this is cash outflow. So that's cash outflow. Put it in brackets like that to differentiate it from the cash inflows. That's cash outflow, brackets differentiated from the cash inflows. So how much will be the NPV here? It will be a negative 17. So 20% gives us the negative NPV. 10% gave us a positive NPV. So what do you think? Coming back to the formula like this one, I said A rate is the one that gives us a positive NPV, B rate gives us a negative NPV. So what are we going to take for A? A percent is going to be 10%. A percent is going to be 10%. B percent is going to be 20%. And what will be the value for A? A will be 73 and B will be negative 17. So let's calculate the internal rate of return. So bring down your formula. Bring down your formula. Let's get the formula down. Okay, so there we have it. Okay, so it's time to apply. So internal rate of return equals internal rate of return equals so we added A percent is the 10%. The value of A on top there is 73. That's what we have calculated from the table. And down there we have 73 minus, now this is a negative value, so it will be minus negative 17. So do it like that. Then you come to B. What is B? We have concluded B should be 20% and A should therefore be a 10%. So we have that. So let's see where this is going. We bring down the formula there and edit. This is a 10%. We have it already. This is 73. We have it there. 73. The denominator here, you see, a negative multiplied by a negative will be a positive value. So 73 minus negative 17 will result in 73 plus 17. So 73 plus 17, how much value will that be? That is something like 90. Then when you subtract 20% minus 10%, you should have a 10% there. So this will be the result. Now finally, tap everything in the calculator. How much will be your internal rate of return? Internal rate of return will be equals to this is going to be 10% plus the resultant from the figures we have in the brackets should be 8.11. So put together your internal rate of return will be equals to 18.1%. 18.1%. So all projects should be assessed using 18.1%. An investment that does not yield more than 18.1% return should be rejected in this case. That's the internal rate of return. So today we've looked at the three important investment appraisal techniques: the payback period, the net present value, and the internal rate of return. Just going back to payback period a little bit, so I can emphasize on something. Sometimes, because a normal payback period does not take into account the time value of money, so sometimes companies can use discounted cash flow payback period. What does that mean? It means you start by, first of all, discounting the cash flows, converting the future cash flows to the present values, and then calculate the payback period based on discounted cash flows. Well, thank you so much for listening to me. We are hoping that this video will be of much help to you, and we intend to circulate this video to all our students at ZAPTAC, and we wish you all the best as you are preparing for the exams. Please make sure that you have a positive attitude towards these coming exams in June. I know many of you will be writing in June. So thank you so much once again. I'll do more videos for you so that we can help you even as you are quarantined. God bless you.